Polynomial functions. This is from section 4.1 for Chatfield. We need to discuss polynomial functions and the names. Now, certain things about polynomial functions. One, they must be in proper order. All right. Now, when I talk about names, I talk about what are they basically called. And it's described by their highest power. This one doesn't have a power, it's just a plain number. This guy is called a constant. This one is called linear. His highest power is a 1.
How many choices could a cheese lover choose if a cheese lover could choose choices? 2. It's the extra cheese and choose pizza from Donato's. We add the cheese, you choose 2 toppings for just $14.99. Donato's. Every piece is important.
As you notice, they're starting to count up. This one does actually have a power. It's a power of 0. So basically 0, 1, 2. Second power, highest power in the equation, is quadratic. These are the ones you probably already know. Previously, we talked about the number of terms. We called him a trinomial. Now we're talking about by his degree. Now, when I talk about degree, this is what I'm talking about. This is a first degree. This is a second degree. It is the highest power of the polynomial function. They have to be in order from the highest power to the smallest, down to the constant. If they're not in order, you have to put them in order. All right? So, of course, the next one. This one is a third degree polynomial, and his official name is a cubic. He has 2 terms, which we talked about previously. Now let's go one more. This is a 4th degree polynomial. Has a power of 4, has the highest power. And his name is quartic. All right. Now, again, you can see how they counted up by the powers. Has to be in order. Now, what's the importance of the degrees? Well, 1, it tells you the name of the function. Quartic, cubic, quadratic, linear, constant. 4th degree, 3rd degree, 2nd degree, 1st degree, constant. Leading terms. The leading term is the term that contains the highest power. If it's not in order, the leading term is still the term that contains the highest power. The leading coefficient, in this case, in this one would be a 6. in this case would be a 7, 2. All right. So leading term, again, whole number is the first term. But what is the importance? Again, going back to that degree. Well, we're getting ready to graph these things. And when we go to graph them, it tells us how many times each one will cross the x-axis, or how many zeros. Because you can have real zeros and you can have imaginaries. So this one has potentially 1 0, which it does, I'll be honest, because it's a linear. This one potentially has 2, it's a second degree. This one has 3, and this one has 4. That is the importance of the degree. It tells you how many zeros each equation has. All right. Now, the other importance on this is, we're going to look at a couple real quick, and this is a handout, guys, that I gave you. Let's look at this. This one real quick. That would be what? The degree would be a 4th degree. The leading term would be a 2p to the 4th. The leading coefficient is a 2. And its name is a quartic. All right. Now remember I said naming it by the highest degree. I want to draw your attention to number 6. Most students will try to say this is the leading term, but my answer on that is no. Again, you look for the highest power. The highest power is actually here. So your leading term is a -6. Well, that should be a to the 3rd. Sorry, guys, that's a typo. You have a typo. So that really should be 6a to the 3rd. All right. So the leading term is 6a to the 3rd. The leading coefficient is a 6. The degree is 3. It's a 3rd degree polynomial. And its name is cubic. All right. Go ahead. Finish this. You can find the answers to this, because remember I told you guys, CUDA, the answers are out online. If you type in naming polynomials and Google it, you will find the answers to this worksheet. Okay? But this is naming polynomials, and keeping this short, I'm going to finish 4.1 about finding zeros and multiplicity in another video.